Alright guys, welcome back to another session of Learning Unity with me. Where we last left off, I think we're still trying to implement the shooting feature for our game, and let's see what we have so far. So I know we're able to move now, and we added some padding in our clamp, right? We normalized the camera and whatnot. But basically, what we did yesterday was we added padding so that the player can now like move without getting too far off the screen. So the player sprite can still be seen no matter how much the user tries to make it leave off the screen, essentially. And oddly enough, I don't know why this spawned. Maybe it's a glitch because sometimes it does spawn, sometimes it doesn't. Let me try again if it spawns again. It does. Wow. I wonder what happened. Oh, is it because I pressed the mouse click? Oh yeah, because technically, right, I made it so that the mouse click also gets read as the fire portion in our code. Let's look at the script here. Yeah, so we need to add velocity in there, and let's see. So in our fire, we are listening for any of the fire 1 inputs, which we can find in the project settings, and yeah, it's going to be in our input manager, and it'll be under the name fire 1, and the main button to activate, or that this manager is listening to, is a spacebar for fire 1, but we also have an alternative button which listens to the left click of the mouse, which is right here. So that's why it does that. I always got confused by it. I think I was kind of confused by it yesterday. So it wasn't a bug, it was just me not knowing what I did. But alright, let's continue with learning how to probably apply some physics into the laser. So I have a feeling, yeah, he's about to do it. We're going to add a rigid body to the laser. Oh wait, we can do it like this. Oh yeah, we also made the lasers, which we first we need to reference the prefab of it, and we can use instantiate to duplicate a prefab on the position and rotation. Quaternion, well, that's how you pronounce it. Identity basically is saying that we want to match the rotation with that of the player, which is right now nothing, so because the player is not rotating at all. Yeah, so we don't need to, so basically it's just saying no rotation at all, but here we just make sure that it's on the position of the player, and we're gonna definitely change that because we're gonna make it match towards the gun. So I think right now it fires from here, maybe what I'm thinking, but then what I want is to be fired from here, so I might need to create my own custom adjustments, because I might be using this sprite over the spaceship that he uses over here, and yeah, right. Alright, sorry, just something I brought up just as a review for myself. Alright, I'm not sure what just happened. So we are storing the object that we create using the instantiate method into a reference. But I assume that let's see what instantiate returns, because then I'm thinking, is this how C# cast does casting here? I'll need to search that too. Let's see. So instantiate. Wait, I spelled it wrong. Instantiate. So let's see what it returns an object. So that's why we need to cast it as an object. We might need to casting explicit. Oh no, it's regular. Huh. But what does the as do? The as operator keyword, what does that do? In the development of software, typecasting is an inescapable thing. In many cases, developers need to convert an object type into another object type, and sometimes he/she may get invalid cast exception. So to overcome such types of exception, C# provides an as operator keyword. So this is only for C#, not the other programming language. All right. So the as operator. The as operator is used to perform conversion between compatible reference types or nullable types. Conversion between compatible reference types or nullable types. This operator returns the object when they are compatible with the given type and return null if the conversion is not possible, instead of raising an exception. Oh, interesting. The working of as operator is quite similar to is an operator, but in shortening manner. It kind of reminds me of instance of, which is used in Java. I think it might be used in other languages too, which is kind of like a boolean. If it's not an instance of, it returns null. If it is, then it returns a casted version of the object that you're looking for. So in this case, since this only returns an object, right, it makes sure, I guess, that laser prefab is of game object type. So I think because laser prefab is a game object type, we are able to typecast it into game object. But let's say laser prefab wasn't a game object, right? It's like some sort of different type of object. Then this would return null. And I think the reason why C# does it, or the way they do it's because they mentioned here that if we're trying to, cast it the normal way, which is like the parentheses, and then you type in the type or the object type within the parentheses next to the object that we want to convert to. If we do it that way, it can lead to some exceptions, like invalid cast exception, which you'd have to think about that ahead of time, right? But I guess here it makes it a little bit simpler for us, or like less worried. Like we don't have to worry too much about it if we do it like this, because then it'll just return null, and then that's won't break our program, right? And we don't want that. We don't want to break our program at all. So I think all right, so cool. That was actually pretty simple as I thought. Our keyword. Yeah, I like what he did here. Like, it looks a lot neater. Because if you're gonna have to read code and you have to do this, oh no, that's terrible. I mean, it's not like I guess like if it's not a serious program and and it's just like, let's say your own personal code, then like you do you, I guess, right? But if you're gonna work with other programmers and they see that, right? But I mean, I guess their screen is big enough, right? They can probably see it. So I don't know. I guess it really depends on the situation. But for my situation, I think it would have been better since it's a lot easier for me to read like this. Oh right, we need to add a rigid body. Alright, let's go do that real quick. So we're gonna go to our prefab, compiling. Alright, so we got our prefabs, go to laser, player laser, and yeah, one thing I know is he labels them like player laser, which is, I think, yeah, it was pretty good, because I just labeled it laser, and then I realized that in the long run that would be kind of confusing since it's too vague. But let's see here. So we gotta add a rigid body. That's because we need to add some physics, which is velocity. So whenever we do that, we need to make it a rigid body. But if the object it does not require any physics calculation by the engine, then we don't need rigid body. We just need a collision for it. Or that's what I've been paying attention to. Yeah, this is the rigid body. We created a rigid body, so now we can, start doing the code that he did, which is the laser dot get component, and then it'd be the rigid body 2D. So now we have reference to the rigid body 2D, and I guess we're gonna add to the velocity maybe. Oh, we're gonna set a value for the velocity. Vector 2. And I'm feeling, yeah, right. And we're gonna create a serialized field, I think. Wait, I like to put all my floats together. Maybe 1F. ten F, wow. Alright, we're gonna try it out. So we added the velocity. So now it should, oh we have compiler issues. What is it? Rigid body cannot be found. Are you missing? Are you using direct type rigid body 2D? So I think we're missing the namespace, using the namespace for it. So I forget which one it was. Let's just look it up real quick. So it uses Unity engine. Huh. Did I spell it right? rigid body 2D. Or I might have get component. Oh, I see. My bad. It's lowercase. Alright. Come on. Yes. Cool. Let's maximize it. I just want to see how cool it is in big screen. Alright. That's actually pretty funny. It kind of reminds me about something. Like maybe, I don't know. So we gotta definitely change the gravity for a project. we don't want any gravity, so we'll probably go to physics 2D and then set this to 0, and then let's see how that works now. Ooh, nice. There you go, that's what I'm talking about. Pew pew pew. Maybe I should do my own voice and just put that as a sound effect and say pew. Wait, did we go back? Oh yeah, because I was looking at the rigid body. That kind of makes sense, because I was also thinking when I did that, like what happen if we need gravity for like other things? So you can actually edit the gravity of specific objects that have rigid body. So let's go change that back real quick. It was negative 9.81. And then here, just change it to 0, and we don't want any drag, like you said, because we don't want this thing slowing down. Yeah. Let's. Oh, and then we can just go. Right. We learned about that body type. They're different body types: static, kinematic, dynamic. I guess it's been a while. I didn't really think about it. The dynamic, I guess, does get affected by gravity, and kinematic just focuses on the motion rather than like physics being applied to it. Yeah, that works too. I'm gonna change it to kinematic. Oh, it just takes everything away anyways. I see. Oh, 20, yeah. Seems like a good speed. I'm gonna make a default in here instead. I made a default in the inspector, but I think this is fine too. But what I realized is, none of these are getting deleted. Let's go follow. Where did they go? Oh, they're still going. Oh wow. But yeah, we don't want that. We want them, because that does add up over time, and I think we need to manage those resources. Coroutines. So let me see if I understand this correctly. A method which can suspend, otherwise known as yield, its execution until the yield instructions you gave it are met. We have this example: when a player gets to 0 health, start the kill player coroutine. So the coroutine involves triggering the death animation and then using the yield. So we're basically waiting for 3 seconds so that the death animation can play, and then restart the level. So basically, usually if we didn't have this, once the user's health depletes to 0, it would just restart the level. But let's say if you wanted to add some death animation to kind of increase the immersion of our game, we would want to play it out, right? So we would need to use a coroutine that seems like it suspends a method, which is kind of odd for me. Like I didn't know about that, but you can suspend like the method. So kind of like, wait. A method which can suspend, otherwise known as yield, its execution until the yield instructions you gave it are met. So and he gives an example: when player gets to 0 health, start the kill player coroutine, trigger the death animation, yield, wait for 3 seconds, and then restart the level. So is that the whole coroutine? But I thought the coroutine was just yielding. Or the coroutine involves yielding, where it waits for certain instructions to be met before executing restart level method. I'm just gonna go look at it real quick, and then we can just continue. Coroutine. So coroutines has a manual for it. Coroutines are computer program components that generalize subroutines for non-preemptive multitasking by allowing execution to be suspended and resumed. By allowing execution to be suspended and resumed. Coroutines are well suited for implementing familiar program components such as cooperative tasks, exceptions, event loops, iterators, infinite list, and pipes. Alright. When you call a function, it runs to completion before returning. Oh, I see. So basically it suspend. Oh wait, did it say suspend? Oh, it does say suspend. So let's say we call a method, right? Let's say at a certain part we need to wait for something to happen before we finish the rest of the code. So let's say like, oh, we need to, wait for the death animation to play. So then when that yield instruction would just hold off here until the instruction is met, or like maybe let's say like it returns a boolean that says, "Are you good to go?" and then it starts executing the rest of the line, rest of the code. I guess that's the best thing I can see it as. It kind of makes sense a little bit. But let me see. Consider a task of gradually reducing an object's alpha opacity value until it becomes completely invisible. As it stands, the fade function will not have the effect you might expect. In order for the fading to be visible, the alpha must be reduced over a sequence of frames to show the intermediate values being rendered. However, the function will execute in its entirety within a single frame update. The intermediate values will never be seen and the object will disappear instantly. Yeah, because I remember in my university, we did go over what yield does, but it was kind of confusing for me. They say it's kind of like generators, like it doesn't hold any, like the objects are being generated, but it doesn't get stored into memory or something like that. And basically, it's like it works like a return. From what I remember, it's been a while, but yeah, it works just like a return, but it doesn't store any of the values in memory. I don't know. Sounds a little bit confusing when I said it. You know what? I think for now, I'm just going to go to what I just said, where we just wait for an instruction to to be met so that we can continue with the rest of the code. I think that's what I'm gonna go with. All right, let's go. So StartCoroutine is an actual keyword that Unity engine looks for. Oh yeah, enumerator. So returns an IEnumerator type, which basically allows us to iterate through all of the things that are being returned to, so that we can go through each one. Right, I think. So the method of our coroutine has to return an enumerator or IEnumerator type. And let's just quickly look at that too. IEnumerator. I think it's a C# thing. Yeah, it's only C#. So it says supports a simple iteration over a non-generic collection. So yeah, so this allows for iteration of whatever objects it's being returned to. Create a simple coroutine. Yeah, that helped. I was like getting confused. Like, how do we do the second? Do I have to take the current time, subtract it by the new time, and then you just gotta keep subtracting until 3 seconds have been met? But yeah, thank you for that. Thank you. Alright, so our challenge is to create the coroutine. This is just for practice. Let's see here. So we're gonna create a. You got to create the IEnumerator method, right? So we're going to be private IEnumerate. Is it IEnumerate or IEnumerator? Oh, it says it right there. What am I saying? The enumerator would be wait, or we could say we don't want to copy WaitForSeconds. How about practice coroutine, and then so basically we have things to do. Say print before yield, and then yield wait for instructions before continuing. And then we do yield return new wait for seconds 3. So I think it's readable like that by itself. I don't need to put comments. So I just want to see what that is. Wait for seconds. So this is part of the Unity namespace. So suspends a coroutine. Oh, so this is actually mainly for coroutine. I wonder if we do use this a lot. Suspends the coroutine execution for the given amount of seconds using scaled time. The real time suspended is equal to the given time divided by time scale. See WaitForSeconds real time if you wish to wait using unscaled. So there's scaled and then unscaled. Still I'm not sure what that means. WaitForSeconds can only be used with yield statement coroutines. So we can only use this when we're using yield. Interesting. Alright, so then waits instructions and then things to do. I just realized something. It's actually debug log. I think print would work if I was using like a C# compiler, but we're using the engine, so we won't be able to see it. Colon right here. So yeah, we gotta look at the console. Oh wait, I didn't even call it derp. Yeah, I forgot to call it. Oops. So we actually have to call it the start. So we have to do start coroutine, and then we do practice coroutine. And then start coroutine a Unity thing, or is that a C# or like yeah, it's a Unity thing. Right. But let me just quickly look at it. So we always do that. Start the coroutine. Basically, the execution of coroutine can be paused at any point using the yield statement. When a yield statement is used, the coroutine pauses execution and automatically resumes at the next frame. See the coroutines documentation for more details. Coroutines are excellent when modeling behavior over several frames. The start coroutine method returns upon the first yield return. However, you can yield a result, which waits until the coroutine has finished execution. There is no guarantee routines end in the same order they started, even if they finish the same frame. Interesting. So yeah, I think that's a very important thing you gotta look out for when you're using this. There is no guarantee coroutines end in the same order they started, even if they finish in the same frame. Yielding of any type, including null, results in the execution coming back on a later frame, unless the coroutine is stopped or has completed. Note, you can stop coroutine using stop coroutine, stop all coroutines. Coroutines are also stopped when the mono behavior is destroyed if the game object the mono behavior is attached to is disabled. Coroutines are not stopped when mono behavior is disabled. Alright, I see. So let's try it now. Did we get an error? No, we didn't. Alright. Cool. Nice. Alright, let's continue. Yeah, I wonder if there's any other coroutine like type objects that we can use for it. So it seems like the standard is to use coroutines in such that it doesn't get spammed a lot. That's the right way to say it. Also, that's why we learn coroutine. Before I go to the next video, I do want to kind of brainstorm what he meant, because he said that the reason why we need this introduction to coroutines is so that we can adjust the rate of fire in respect to the amount of time the user taps on the fire button, which is in our case either the space button or the left mouse click. So how would coroutine work in that sense? Would need to yield, right? Yield for something, wait for instruction. Maybe holding down the button. So we'd wait till the button has been let go. One of the fire buttons have been let go. And if that's the case, then continue. I'll go with that for now as I go to the next video. I wonder if he ever talks about memory resource. Shredder. No, it doesn't say it. Hopefully he does go over it, because I don't know, seeing all those laser objects not getting destroyed, I feel like that can be very bad in terms of using memory. We can just comment this out for now just to practice. Probably put this at the bottom. And then we can just delete this. Alright, so we gotta convert this method, it seems like, to a an IEnumerator so that we can, or no, rather, we're trying to make it as a coroutine. So we're gonna save this. I do want to hold it, but I'm not gonna use it. We're gonna do private void fire. Oops, that IEnumerator fire continuously. So basically, we just copy paste this. Wow, that's terrible. Right. So then we're gonna take this out. So I'm just gonna put a comment saying and reference functions. So these are for like learning purposes. We just put them at the bottom, so we don't have to care about them as much. But we can always just reference them when we can, just in case if I forget something. So yeah, all right. So we have fire continuously, and then I'm thinking that he's gonna want us to put it here, but he just mentioned about like being cautious of doing that. Alright, so we created the fire continuously. Now we need to yield return what? Yield after projectile firing period has elapsed. Oh, I see. So it looks like we can continuously press down the button until a certain amount of time. No, I'm not getting this. Let me see what he said again in the beginning. Shoot and then yield and then shoot and then yield. Alright, so we need to yield. So we instantiate the laser. And then for each laser, we're going to add a velocity. Oh my god. Yield after projectile firing period has ended. So what would that be? Would that be like a certain amount of time? I guess the way I see it's kind of weird. Because right now I see yield as like, alright, do this, then wait. But here I'm like, if we're gonna fire continuously, then why do we want to wait? Maybe I'm missing something here. I just don't quite understand. Because yeah, I don't know what to yield here. Because we are supposed to return an IEnumerate, which happens when you yield return something. So when we hold down the fire button, we want to create the laser and then wait. I'm not getting it. I'm just going to continue, unfortunately. Maybe I'll understand when he shows it. Oh, wait. You're supposed to create another method along with fire. Got it. I didn't know that's what he wanted. it up here. Then I guess we can delete. Actually, I don't know what to do after that. It says to convert fire to fire continuously. So I just thought we were supposed to convert it to a coroutine, but I guess not. So then the yield. So this is a mini challenge, and unfortunately I failed the other one, but hopefully I can get this one right. What I'm guessing is that is there probably a method that says get button up, and we just learned, right, in the while we were reading the StartCoroutine documents, that there's also another method called StopCoroutine. So when the button goes back up, basically we released one of the fire buttons, right? It's gonna stop the coroutine, which will end the while loop that happens here. But I guess I just don't understand the yielding. Like, what are we, like, wait for seconds? Like, what are we waiting for? Don't we want it to keep generating new lasers? Unless that wait for second. Wait, I have an idea. So maybe that. So, alright, maybe I didn't quite piece the puzzle quite yet in my head because I was like unaware of what he was planning. But the while loop does make it more understandable. Because, you know, if we didn't wait for any seconds, right, then the laser would just all, you know, be so stuck together that it just looks like one line. And I think I'm gonna try that out right now just to demonstrate what I mean. So let's go ahead and do that. While true, this, push it here. Can't see any of the code because it's like going to the right. Alright, and then I'm gonna implement what I think. Do I get button up, stop coroutine, fire continuously, and then if we change this to 0, what would happen? So actually, let's just try to see if it works, and then we'll change it to 0. Hopefully no compiler issues. Nice, nice, nice. I just guessed on the get button down. I didn't even know if that was the actual method or not. Oh. Alright, so my solution didn't work, but let's see if we change this to, notice how there was like a little separation in between them. Now let's make it to 0. Let's see what happens then. What I'm predicting is that there's no gap. It makes it look like there's no gap in between them, which doesn't look as well compared to, you know, adding that 0.1f, which delays shooting the laser after a certain amount of time, which creates a nice gap to make it look a little bit more pleasing, right? Yep. I guess I don't know. It's 0. Yeah, it does return the same thing. So I guess, yeah, I'm really questioning why we need this then. I'm kind of confused at this point. Like, why do we need this? If we have 0, it works the same way as if we didn't need it. My head. So then my only guess is that maybe we just needed to yield something, right? We just need to call this while loop so that we can control the coroutine by being able to stop the coroutine. Maybe I just didn't do this properly, but I think this is the solution. Yeah, so that's now my only guess. So logically it didn't quite make sense to me in the beginning because I was confused as to what we needed to return. The kill animation example was really good because I thought, like, yeah, that makes sense to wait for the animation to play out before you do anything else. But here, if we wanted to shoot continuously, then why did we need to wait? So it didn't make sense to me. But I think now I know why we need to do that. It's because we need to be able to control whether, I mean, when he added the while loop, that's when it started making sense. By adding the while loop, it does make it so that if we press down the fire 1 button, which is the space bar or the mouse click, it's gonna activate this while loop, right, until this while loop coroutine. And because it's a coroutine, we're given the option to stop it, and we can do that. Like, that's what the solution was supposed to be. Maybe I messed up something, but I feel like we're gonna have to use this. So let's go check it out first, and I'll give my final thought about it. Oh dang. I think it would work, but I think that wouldn't be proper since you. Yeah, I don't want to use that when it's not necessary. Oh, that makes much more sense. That's why it didn't work, because we needed to stop this specific coroutine. I guess, yeah, I didn't think about it. This would reference to a different. Um, Actually, it wouldn't even reference the coroutine, the one that we started. It would actually reference to a coroutine that hasn't been started, because they're kind of technically two different objects, but because different calls to the methods lead to different IDs to them, if that makes sense. So yeah, this one doesn't refer to the one that we started. So we got, I think what he's about to do is he's gonna create a reference to this, so then that way we can then stop that specific routine that we started in when we held down the fire button. Let's see if it works, because I am running out of time. It's almost 1 hour, but I will try to finish this, just this part only, to see how it is. Alright. Yeah, that's way better. But again, look at all those objects. We're gonna keep going on and on and on and on and on and on. Holy moly. Let's go back in. So yeah, it works. So yeah, my final thought about this. Yeah, I think that's what I'm gonna do. I'm just gonna say my final thought and then end the video here. So yeah, so it seems like even though like this yield routine, like I still don't know what it does, and I should have tested it. I will probably test it when I come back if I remember. But essentially, the only reason why we would, make a coroutine is because of this while loop here. This while loop would keep going on and on and on until we stop it. And we would stop it if we let go one of the fire buttons. Yeah, I mean it works, and I do find it interesting. But I guess when he gave us that earlier challenge, and I might be salty here because I couldn't figure it out. But yeah, because I didn't quite understand why we needed to return, or why we would need to wait if we're gonna fire continuously. And yeah, I guess that's my final thought about it. It's still pretty cool. I did learn something at least, and yeah. Well, alright guys, so I'm gonna end it here, and I'll see you guys tomorrow. Peace.